University of Auckland.
Yes.
Ready?
Right.
Hello, so I'm here with Alistair Young from the University of Auckland in New Zealand. Thank you very much for joining us. What have been your highlights so far of the conference?
Well, we had a great session this morning at 8 o'clock on artificial intelligence and machine learning, and that was very well attended and also had a wide range of speakers, from people talking about the physics of reconstruction of imaging, right through to diagnosis and reporting. And I think that people took out a lot of information from how these new technologies can make a real impact in their daily work.
And regarding cardiac MRI, what is deep learning?
Well, it's deeper than the shallow learning that you've been hearing about all the time now. It's basically the same technology that's been around since the 90s, neural nets. And so people have taken their inspiration from the physiology of neurons in the brain and the way they interconnect with each other. And the idea is that if you connect these neurons together, then they can make decisions about things. And it's a pattern recognition process, and the mathematics have been around for a long time, but what's changed is the computing power and the ways that the algorithms are using to optimize their solutions. So that you can think about them as very good pattern matching methods. And the deep part comes because there are a lot of layers in this neural network, much more than there have been, and that's been enabled by this computational power that's now in the NVIDIA graphics cards. So you can thank all the teenagers who do online gaming. That's been the big impact.
And how do you see us applying these techniques into cardiac MRI?
So it can have an impact across the board, and we're only beginning to get an idea of how that can happen. So what's happened already is in the processing of data after the acquisition. So the days of drawing circles on images are now gone. The computer can now automatically draw outlines of the left and right ventricles. So that works pretty well. And where we're going to see impact in the future is shorter scan times. So compressed sensing has made inroads into this field, so now you can get images with much shorter time frames, free breathing, and in the future this will become even more doable in practice. The advantage of this approach over compressed sensing is that you can learn how the compressed sensing algorithm gets to its solution and then apply it in a much quicker time. So instead of waiting for 5 minutes for your recon to actually appear, you can get it immediately.
And what do you think are the challenges that we need to overcome as a CMR community to get this into clinical use?
Well, we need to be skeptical about some of the more outrageous claims that people are starting to make. There's been a lot of enthusiasm for that technology, and maybe that has been kind of overstepped. So we're in a cycle now of a new technology making its mark, and then there's a kind of a backlash, and then there's a consolidation, and then actually real work happens.
Fantastic. Brilliant. Well, thank you very much for your time, and enjoy the rest of the conference.
Pleasure. Thanks very much. Yeah.